Hello and welcome to this second video in a series on nitrogen chemistry aimed at National 4 and National 5 level. Right, in the last video we looked at the nitrogen cycle and we saw that all living things need nitrogen compounds. Now notice this is nitrogen compounds, what we call fixed nitrogen. It's produced from nitrogen in the air by bacteria in the soil and in the roots of some plants like peas, beans and clover, but also by lightning in the air causing nitrogen and oxygen to react. So these nitrates allow plants to grow and result in nitrogen compounds being passed around the food chain. Eventually though, the nitrogen compounds wind up back in the soil because decomposing bacteria break down dead animals, dead plants, but also particularly animal waste. Animal waste, of course, we can use as natural fertilizer. There's also denitrifying bacteria that return nitrogen to the air. Okay, now over the last few hundred years, the human population, the number of people on the planet, has increased enormously. That means the amount of food people need has increased enormously. And that's led to the use of artificial fertilizers. That's man-made fertilizers. An example is this bag here. Now notice those letters, NPK. These represent some really important elements needed for plant growth. In particular, the N stands for nitrogen. And nitrogen is important for photosynthesis to take place. If you want rapid plant growth, if you want plants to grow rapidly, you want a fertilizer with lots of nitrogen compounds in them. P stands for phosphorus. Phosphorus is important for releasing energy from carbohydrates, not just in plants but in animals. And the K is potassium. And that's important for getting carbon dioxide into leaves, but also if you want to promote flower growth, fruit growth, so flowers and fruits, what you want is lots of potassium in your fertilizer. Notice, by the way, those 19s, they are the percentages of each element. You'll realize they don't add up to 100 because, again, we're talking compounds here. Nitrogen compounds, phosphorus compounds, potassium compounds. So there are other elements in here, particularly oxygen. Okay, we talked about nitrates being important. So how do we make nitrates? Well, the easiest way is by neutralization of nitric acid. So we take some nitric acid and we neutralize it using potassium hydroxide. There we go, there's the equation there. Potassium hydroxide plus nitric acid goes to potassium nitrate and water. Another useful one is ammonium hydroxide, which will give you ammonium nitrate. Notice you've got two lots of nitrogen in there, which is kind of nice. If you want to make phosphates, you'll need phosphoric acid, and potassium hydroxide can neutralize other acids to make other potassium compounds. But we're focusing here on nitrates, which you can make by neutralizing nitric acid. Notice these are solutions. Look at all those AQs in those equations. Nitrates are highly soluble in water. This makes them again useful for fertilizers because you need your fertilizer compounds to be soluble in water so they can be absorbed by plants through their roots. There is a problem particularly though with nitrates being highly soluble. And that's what we call algal blooms. Okay, let's take a river. There's a river. And in the river you've got fish. Those fish are swimming around quite happily, but they need oxygen dissolved in the water to allow them effectively to breathe. Like all animals, they need oxygen to carry out respiration. And that's dissolved in the water and plants absorb it through their gills. Also usually on the surface of rivers there are tiny plants called algae growing. Usually this is not a problem, there's a nice balance there. Okay, but suppose we grow some crops in the fields next to the river. We've got cabbages here. I don't know why I chose cabbages. I don't even like cabbage. But we've got cabbages, say, growing in those fields. Now, to encourage plant growth, we're going to put fertiliser on those fields. Let's put some nitrate fertiliser in there. Now, that nitrate fertiliser is highly soluble in water, needs to be soluble to get into the roots of the cabbages. But suppose we get some rain. Does happen occasionally in southwest Scotland. That rainwater can wash the nitrates out of the soil and into the river. Because it's highly soluble, the rain can dissolve it and carry it into the river. Now, once in the river, it'll do what fertiliser does. It will encourage the growth of plants, in this case, the algae on the surface of the river. Now, what happens is if you get too much algae on the surface of the water, that algae rots and decays, and that absorbs oxygen from the water. So having too much algae, what we call an algal bloom, having too much algae will absorb oxygen from the water, effectively remove oxygen from the water. But the fish need that oxygen to survive. So if you take oxygen out of the water, I'm afraid poor old fish has had it. And that's the problem, is that if oxygen is absorbed from the river due to nitrate runoff, then life in the river dies off. Okay, so what do we now know? We now know that nitrogen, phosphorus and potassium are important for plant growth. So artificial fertilizers contain compounds containing those elements. And those compounds can be made by neutralization. In particular, we're interested in nitrates, and nitrates can be made from nitric acid. But these nitrates are highly soluble and are easily washed into rivers, and that can result in algae multiplying out of control in a way that kills fish and other river life. Okay, that's all for now. Thanks for watching.